Welcome students. In last class we saw introduction to a method which is known as method of integration by parts. In that method we saw that a product of two functions can be integrated by using a certain formula. We developed the formula. We saw an example also. So, let us write back the formula. So, for two functions f x and g x, the integration of the product is equals to f x integration of g x dx minus integration differentiation of f x, which is f prime x, integration g x dx and then dx. So, this we call method of integration by parts. So, it is one of very useful technique to use this method, and we will see in some time that how good we can use this method to solve certain integrals. If you remember or recall the previous class, we considered this function as first function and this function as second function. So, it helps in memorizing this particular formula. So, what it says is that integration of the product of two functions, which we will call as first into second, as first function integration of the second minus differentiation of first integration of the second and then whole integration. So, this is how we recall that integration of the product first function integration of the second minus differentiation of first integration of the second. So, I will keep on referring this formula in that manner. If I look at some more example, so let us try for the integration of x squared e raised to power x. Now, again I can use the same technique and I call this as first function and this as second function. So, the integral will become first x square integration of the second function e raised to power x dx minus integration differentiation of the first function, this is 2 x integration of the second function e raised to power x dx and then dx. So, this entire thing becomes x square e raised to power x integration, you know it is e raised to power x, as I told you we do not need to put a constant here, minus 2 can be taken outside integration x e raised to power x has integration as e raised to power x dx. So, we reach to this x e raised to power x, we have already evaluated. So, now we know that we can evaluate it further. So, same method as we used in the previous example, twice put a square bracket here. Again you consider this as first function and this as second function. So, first function integration of the second minus differentiation of first integration of the second and then whole integration. So, this entire thing will take you to x square e raised to power x minus twice of x integration of this function will become e raised to power x minus integration e raised to power x dx and then finally x square e raised to power x minus 2 x e raised to power x minus minus plus 2 integration will become e raised to power x and then a constant of integration. You could have also added a constant of integration here, and finally it will be this. So, the integral of this function x square e raised to power x comes out to be this. Let me take another example for you, which involves trigonometric functions. So, let us evaluate x sin 3x. Again we take this as first function and this as second function. Now, I think there should be a question in your mind that, I mean, why are we choosing this as first function and this as second function? So, we will see that in a moment, that there should be a proper choice made for first function and second function. Many times we choose the function as first function, which helps us in reducing terms in the integral, since the formula goes like first function integration of the second minus differentiation of the first integration of the second. So, we have to keep couple of things in mind. So, here in this case, if I take x as first function, then the derivative vanishes. So, that is the thing which I am keeping in mind, but there are a few other things also which we should keep in mind. So, let us first solve this example. So, here the integration says first function integration of the second minus integration differentiation of the first integration of the second whole integration. This gives me x. Integration of sin x, I know it is minus of cosine x, and this function is a linear term, therefore, I can write the derivative in the denominator. So, this becomes minus cos 3x over 3. So, we already have talked about this one, that integration of f of a x plus b dx is capital F of a x plus b by a plus c, provided we know that integration of f x dx is capital of f x. So, we know that integration of sin x is minus of cosine x, therefore, it will become cosine 3x divided by the derivative of this fellow. So, it's I have used this property. You can even substitute 3x is equals to t and then you can integrate it, it is not a problem now. Minus integration 1 times integration of sin 3x is again minus cos 3x by 3 dx. So, this term goes to minus of x cos 3x by 3 minus minus plus 1 by 3 integration of cos 3x dx. A little care should be taken at the beginning, that is why I am writing all the steps. So, once you get acquainted with this calculation, you can skip couple of steps and you can write them. So, minus x cos 3x by 3 plus 1 by 3, again integration of the cosine 3x. I know it is using the same formula, I know integration of cos x is sin x, and therefore, this becomes sin 3x by 3 plus the constant of integration. So, it becomes minus x cos 3x by 3 plus 1 by 9 sin 3x plus the constant of integration. So, integration of x sin 3x is this. Now, can we continue with the similar process? Let us choose another example. This example will motivate us to find out or to figure out that which function should be chosen as first function and which function should be chosen as second function. So, assume that we have to find out the integral of x log x. What if I use my similar trick? So, I would have called, I will write it here, x log x dx. So, if I do not do anything new, I will follow the similar procedure. I will call this function as first function and this function as second function. As I told you, this is vanishing. We have to see whether that idea really works here. So, this will go to the first function, integration of second function minus integration differentiation of the first function, integration of second function dx. So, this ultimately becomes x integration of log x dx minus integration of log x dx and then dx. So, the problem of finding this integral I took us to this form, and which has become furthermore complicated for us at this stage, because we really do not know what is the integral of log x. So, at this stage we do not know what is the integral of log x, and therefore, we cannot move further. So, making a choice of logarithmic x as second function and x the choice for the first function as it was vanishing, it did not help us here. So, it is not always the case that choosing a polynomial function which vanishes will help you. It depends on other functions also which are present in the integrand as a product. So, in this case, let us try log x as first function. So, let us call log x as first function and x as second function, then see what happens. So, log x first function, integration of the second, that is integration x dx minus differentiation of the first, that is log x differentiation. So, differentiation of log x is 1 by x multiplied by integration of the second. So, x dx and then whole integration. This leads us to log x into integration of the second x square by 2 minus integration 1 by x multiplied by this integration is x squared by 2 dx. So, notice carefully this x cancels with x here. So, we should get x squared by 2 log x minus 1 by 2 integration of x dx, and this I know. So, this x square by 2 log x minus 1/2 of x square by 2 plus the constant of integration which is coming throughout. So, this will give me x square by 2 log x minus x square by 4 and then plus constant of integration. So, the evaluation of this integral could be easily done if we choose log x as first function and x as second function, while in this case if we choose x as first function and log x as second function, we reach to a problem where we have to find out the integral of log x, which we do not know at this stage. So, making a choice of the function is really important. If you make a choice which is wrong, then you may reach to the evaluation of the functions which will become very complicated, as we saw in the case of x log x. So, it was very simple looking function, but the integral of log x was creating trouble for us. So, the idea will be mostly to choose the function for which the integration does not go on, or it does not keeps on becoming longer and longer, and similarly if we look for that kind of idea, then we can easily figure out that which function we should choose. So, I will give you another example here. So, suppose that we have to find out the integration of x sine inverse x. So, this involves algebraic function and inverse trigonometric function. So, with the previous experience, we know that integration of sine inverse x, this will be troublesome. So, therefore, we will call this sine inverse x as the first function and this x as the second function. So, that the integral becomes sine inverse x into integration of the second is, now I can write it directly, x square by 2 minus integration differentiation of the sin x is 1 by square root of 1 minus x squared into integration of the second is x square by 2 dx. So, this leads to the integration x square sin inverse x by 2 minus 1 by 2 x square or 1 minus x square root dx. So, if I write it as x square sin inverse x by 2 minus 1 half, and this integrand I write it as integration of minus of 1 minus x square plus 1. So, what did I do here? I have added 1 and I have subtracted 1. So, minus 1 plus x square plus 1. So, 1 gets cancelled. So, I will get x square divided by square root of 1 minus x square dx. This I can further write as x square sin inverse x by 2 minus 1 half. This integral will be broken into two parts using linearity property. So, 1 minus x square divided by square root of 1 minus x square will be giving me 1 minus x square with a negative sign. So, this sign will become plus, then again minus half multiplied. So, minus half integration 1 over square root of 1 minus x squared. So, I shall evaluate these integrals into two separate parts. I will call this integral as I1 and this integral as I2. So, now I will write for I1. I1 is square root of 1 minus x square dx and I2 is 1 over square root of 1 minus x square dx. We know for the case of I2. So, this is nothing but sin inverse x. For the case of I1, we may have to go for some trick. So, we need to evaluate this integral. This integral we do not know how to evaluate. So, what we need is that we have to think of some substitution. Well, as it looks like 1 minus x squared dx and a similar integral of this kind we have evaluated earlier. So, it looks like a good choice if I put x is equals to sin theta. So, that I will get here 1 minus sin square theta, which is cos square theta. So, square root of 1 minus x square will become square root of 1 minus sin square theta, which is nothing but cos theta, and dx in that case will become cos theta d theta. So, ultimately the integral I am looking at will become integration cos theta into cos theta d theta because it is 1 minus x square which is cos theta, then dx which is cos theta d theta. So, I 1 becomes cos theta into cos theta d theta, which is nothing but cos squared theta. This I think you can guess now that we can evaluate, since it is a having quadratic term here. So, first of all we have to convert it into a linear form of cosine. Fortunately, we know the formula is cos of 2 theta is equals to 2 cos square theta minus 1. So, which will give me cos square theta is equals to cos 2 theta minus 1 by 2. So, I will replace it by that factor, and then so I will get 1/2 as outside, and this will become cos of 2 theta minus 1 d theta, which ultimately will lead me to 1/2 of cos 2 theta integration. So, integration of cosine, again that property I will use having a linear function here. So, integration of cosine theta I know is sin theta and divided by 2, the differential of this factor, minus integration of 1. So, that will I get as theta. But what is theta? Theta is, I can solve it from here. Theta is nothing but sin inverse x, and therefore, this is written as 1 by 4 sin 2 theta. So, sin of twice of sin inverse x. So, minus of theta by 2. So, theta is nothing but sin inverse. So, minus of 1 by 2 sin inverse x. So, I will simplify this further for you when we will be looking at. So, our integral, if you look at it, the final integral for this particular problem, this turns out to be this long calculation which gives you these factors. So, in the next page I shall write it down for you. What is my integral I? So, my integral I ultimately is, you look at x squared sin inverse x by 2, x squared sin inverse x by 2 minus half of I 1 minus half of I 1, which I will substitute, minus half of I 2. So, I 2 we could easily see it is nothing but the sin inverse x, and then plus a whole constant of integration. Now, look back at this factor, half of sin 2 sin inverse. So, it is not reaching to any form which we know. So, what we do is that we will write it in the form which we know, or which we can further simplify. So, you know sin, this term is equivalent to sin 2 theta. So, therefore, you can write it as, let me simplify it here for you. To sin theta cos theta. Sin theta you already know is x, so it will become 2 x. Cos theta you can write it as 1 minus sin square theta, which you can write as 2 x square root of 1 minus x squared. Simply you can also simplify this also, sin of 2 sin inverse x will be twice of sin inverse x into cosine of sin inverse x, and then cosine of sin inverse x can be written as 1 minus square root of sin inverse x, which is nothing but the same as this term. So, ultimately we will get the same expression which we got from here. So, this is 1 by 4 of 2 x 1 minus x square. So, this expression is 1 by 4 of 2 x square root of 1 minus x squared minus 1/2 of sin inverse x. So, the integral I 1, which we evaluated using this procedure, it is a little long, we got this one. So, when we simplify this, we get finally x square sin inverse x over 2 minus 1/2 of this is 2 by 4, that will make it 1 by 2. So, this will make it x by 2 square root of 1 minus x squared minus 1/2 of sin inverse x and then minus half of sin inverse x plus constant. So, this is the final integral we evaluated after doing this entire procedure. So, we can, with the help of these integration by parts, we can, and using other techniques also which we have learned already, we can figure out the integral of certain functions. Now, we come to the important question of choice of first and second function, which means which function we should call as first function and which function we should call as second function when we are applying this particular formula. So, for that mostly we look at the combination of the functions. It depends on problem to problem, but as I told you that it should not complicate your integral, because you can see in the formula it says f x integral of g x. So, if I take a function which will have an integral which is very complicated or it keeps on extending, then I will be in trouble, because it again involves another integral here. So, integral of the integral, so that may create problems. So, I should be choosing the function wisely where the integral, because I already do not know the integral of the entire product, and if I choose something which will further make it complicated, then I will have trouble. So, I mostly should choose the function which should not become very complicated. There is a convention which says that if you have a combination of the functions which involves your, say, inverse trigonometric functions, logarithmic functions, algebraic, say polynomial, etc., then trigonometric, inverse trigonometric, trigonometric, and then exponential. Exponential usually do not create much problem. So, they say that this should be the convention says that this usually should be the order of the selection, that you should first try to choose inverse trigonometric function as first function if it is present, and this should be in the order, and logarithmic as first function. So, we have seen the case where we have to integrate x log x. So, in this case, you know, algebraic function was present and logarithmic was present. So, according to this order, I should have chosen logarithmic first and then algebraic. So, you saw that when I solved that example that if I choose this as first function and this as second function, the integral becomes very easy, and it was easily we were able to handle it easily. Similarly, we saw the case for x sin inverse x. So, here also the inverse function was first and this was second. So, this also falls in this order, you see, inverse trigonometric and then algebraic. So, inverse trigonometric was chosen first and then algebraic function was chosen as second function, and this is the order of function which should be kept in mind while evaluating. Though for simple functions many times it may not be that difficult to evaluate even if you do not follow the order, but if a function becomes very complicated, it really will be difficult to evaluate. I will show you that for this particular integral, even if you choose this as first function, this can be evaluated, but then it will be little complicated to evaluate. So, now we shall look at the important application of this method which will help us to evaluate certain integrals, which will be very difficult for us to integrate using the known methods. So, we will take one example for you, integral of log x dx. This example will also help us in evaluating the integral which we started with. So, what we do is that we understand it as 1 times log x dx, 1 multiplied by a function makes it same function, and then we apply the ordering method, that which function should be selected as first function and which function should be selected as second function. So, here since log x is present, therefore, I should consider it as a first function, and this algebraic function 1 is a constant function, therefore, its algebraic function should be considered as second function. And if I do that integration by part, it will give me log x integration of 1, I can write it directly now, x minus integration differentiation of log x, it should be 1 by x, again integration of 1 gives me x dx. This entire thing will give me x log x minus x, because x gets cancelled. So, here I will get 1 dx, which will give me x, and then finally, a constant of integration. So, I got this important result log x dx as x log x minus x. So, if I want to go back to the integration of x log x, as I told you that now if I choose this as first function and this as second function, and since it is a simple function, I can if I do not care about the ordering. So, this will lead me to x integration of log x minus integration differentiation of x 1 integration of log x. Call this as entire function as I. So, integration of log x, now I know integration of log x is x log x minus x. So, I can substitute this value here. So, what I will get now x log x minus x, as I told you earlier that constant we can ignore here at this stage. Integration of log x is again replaced by x log x minus x dx. So, it goes to integration, this further goes to x square log x minus x squared minus integration of x log x, and then plus x square by 2, and then finally, a constant of integration. Now, if you look at it clearly, this term x log x dx is nothing but our integrand itself, and therefore, I can write it I. So, I will get x square log x minus x square by 2 plus x square by 2 will give me x square by 2 minus I plus c. So, the expression I got now from here is that I left hand side equals to x square log x minus x square by 2 minus I plus the constant. Transfer I to the left hand side, so that you will get twice of I, and then divide throughout by 2. So, you can directly write it as I equals to, so I have transferred this I to the left hand side, so that it became 2 I and divided throughout by 2. So, x square log x by 2 minus x square by 4 plus this constant c by 2, I can write it another new constant c 1, which further can be understood as the constant. Since it is a constant, it does not really matter that what arbitrary constant you should choose. So, ultimately the solution should look like of this form. So, for this function, if I do the integral of log x, this can be evaluated, but you can see that how complicated the calculation had been if we divert from the ordering of choice of the functions. I will give as another example for you, which I shall not solve. you look for this example, evaluate x square log x dx. Use both the techniques which I told you. First you consider, because here ordering says that log x should be considered as first function and this algebraic x square should be considered as second function. So, first you choose it as first function and x square as second function and then integrate, and then in second case what you do is that you choose this function as first function, this function as second function, and then integrate and see the difference in the calculation and try to learn that. So, next example for another complicated function is integration of tan inverse x. So, for this also I will use the same trick which we used for logarithmic x. Consider this tan inverse x as 1 multiplied by tan inverse x. Write this function, since it is inverse trigonometric function, therefore, this should be considered as first, algebraic function should be considered as second. So, this will be tan inverse x, integration of the second will be x minus integration, differentiation of the tan inverse x will give you 1 over 1 plus x square, integration of 1 will give you x, and then finally dx. So, you see how simple it has become, x tan inverse x minus integration x over 1 plus x square dx. With our practice of problems so far, I think you can easily see that numerator is nothing but the differential of the denominator. So, what you do is that you take denominator 1 plus x square as a new variable t, so that you get 2x dx is equals to dt, that means x dx is equals to dt by 2. So, this integral can be easily evaluated, x tan inverse x minus 1/2 integration of dt by t, and which leads you to the logarithmic function. So, this will give you x tan inverse x minus half logarithmic of mod t plus constant of integration, which finally leads you to the final answer tan inverse x minus half logarithmic of mod of 1 plus x squared and plus constant c. So, the integration of tan inverse x can be easily found in this fashion. So, I will give you another homework exercise. Try to figure out what will be the integral x tan inverse x. Choose the first function and second function yourself and evaluate this integral. So, if you have noticed, when we were finding out the integral of x log x, we used the idea there. We wrote this I function, and when this integration process proceeded, we found that the relationship of the integral turns out to be a certain relationship with the original integral itself. This trick actually sometimes becomes very handy, and we can use it in solving certain problems. So, for those class of functions where integrations of both kind of functions will keep on giving you the functions which will not be diminishing, in those cases this idea works pretty well. So, look at the example. I will tell you how it can be worked out. So, look at the example of taking the integral of e raised to power mx cos nx dx, and let me call it as I1, let me call it e2 e raised to power mx sin nx dx. Here m and n can be any number. So, according to the particular numbers, you can solve them as a particular case. We are considering them as any numbers which are obviously non-zero. So, you know, exponential function, if you either differentiate or integrate, you will get another exponential function. Cosine function, if you differentiate or integrate, you will get either cosine function, so you will get sine function. Similarly, sine function, you will get cosine function. So, for these two functions, I will look for the solution for one of them, and I will choose I2 as the function which I will solve for you. Similarly, you can solve for I1. So, let us write this I2 and choose them as first function and second function. So, since it is a trigonometric function sin x, I should choose it as first function, and according to my order I should choose exponential as the second function. So, the integral will give me sin nx e raised to power mx divided by m minus integration differentiation of the first. So, it is n cos nx e raised to power mx by m integration of the second dx. First function integration of the second, differentiation of the first, integration of the second dx. So, this will give me e raised to power mx sin nx upon m minus this is n by m integration of e raised to power mx cos nx dx. Further, let us integrate it again using integration by part, considering this as first function and this as second function. So, what I will get is that e raised to power mx sin of nx divided by m minus n by m first function cos nx integration of the second e raised to power mx by m minus integration differentiation of the first. So, it is n minus sin nx integration of the second e raised to power mx upon m and then whole integration. So, when we simplify it further, what we will get is I2 equals to e raised to power mx sin nx upon m minus, you can see n by m is squared, n by m is squared e raised to power mx cos nx, then n by m multiplied by this n by m, this minus sign will make this sign as plus, and then ultimately this minus sign will make. So, throughout the sign I will get as a minus sign, n into n, n square, m into m, m square. So, n square over m square integration of e raised to power mx sin nx dx. Look carefully, what you have obtained here is the same as the integral which you started with. So, I can replace it by I 2. So, that I will get here on the left hand side I will transfer everybody. So, I 2 1 minus of n square minus m, n square by m square will come on the left hand side, will become plus n square by m square equals to, if I take this m square as LCM here, we will get m square. So, that m e raised to power mx sin nx minus n e raised to power mx cos nx. Simplifying this will ultimately lead to the I 2, which is nothing but the integration of e raised to power mx cos nx dx equals to m square get cancelled. So, here you will get m square plus n square, which will come in the denominator here, 1 by m square plus n square m sin nx minus n cos nx into e raised to power mx. E raised to power mx is common, e raised to power mx common, m sin nx minus n cos nx. So, this is what ultimately you will get when you simplify this. So, similar procedure you can apply for the case when it is e raised to power mx cos nx, and then similarly you will get the similar formula. So, what is important here to note is that sometimes you can choose these functions and then if you perform integration by part repeatedly, you may get the same function, and then you transfer that same function to the left hand side and then simplify that equation, solve it for that unknown function, and then you can get the integral of that function. So, this method becomes very handy for some particular problems. Next, I will solve for another special function which I used in another earlier problem. So, when I was solving the problem of x sin inverse x for u, I obtained this function I1. This kind of function in fact can be solved in general and found their integral. So, let us look at the function of square root of x square minus a square dx. Similarly, I can do for a square minus x square and a square plus x square. I will do for x square minus a square, and then the rest of them I will tell you the formulas for them. So, suppose that we have to integrate this integral. So, what you do is that we use the same technique as we use for the logarithmic function. We write it as integration of 1 times x square minus a square dx. If you notice the earlier case, it was 1 minus x square. So, the same technique which I am using here can be used in that case also. We used there a substitution, x is equals to sin theta. So, to solve this particular form, we used substitution, x is equals to sin theta, and then we evaluated. But here we are using integration by parts. So, consider this function as first function and this function as second function as usual. So, that you will get x square minus a square, integration of 1 will give you x square by 2, sorry, x, integration of 1 will give you x minus integration, differentiation of square root of x square minus a square will give you 2x upon 2 root x square minus a square. This is the differentiation of first function, multiplied by integration of the second will give you x. This 2 gets cancelled with this 2, and here you will get x square. So, that you will get x square root of x square minus a square minus integration of x square over x square minus a square square root dx. So, further if we look at it, we can simplify. So, you keep on writing the first term as it is minus. If I add and subtract here a square, then I can get a factor out of it. So, I will do this x square minus a square plus a square divided by square root of x square minus a square dx. Easily you can see x square minus a square here can be divided by square root of x square minus a square. So, I will get 2 integral terms here, which will give me first term x square root of x square minus a square minus sin x square minus a square divided by square root of x square minus a square integration square root of x square minus a square divided by square root of it dx, and this minus goes with this. So, it will be minus a square can be taken as common, integration of 1 by square root of x square minus a square dx. Look at this, I is the same as square root. So, therefore, this term I will replace with I. So, my left hand side is I, this function is also I, therefore, the left hand side become now 2I is equals to x square root of x square minus a square minus a square, integration of 1 by x square minus a square is already known to us, and that is the function logarithmic of x plus square root of x square minus a square, and then finally a constant of integration. So, finally, this integral I turns out to be x square root of x square minus a square by 2 minus a square by 2 logarithmic of mod x plus square root of x square minus a square plus the constant c. So, finally, the integral which we have evaluated I will write it for you, dx is x by 2 square root of x square minus a square minus a square by 2 logarithmic of mod x plus square root of x square minus a square and plus constant of integration. The other formula can also be similarly found, and I will write them for you, which you should evaluate. Integration of a square minus x square dx, which was close to 1 minus x square, is equals to x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a plus c. This is the one which we observed in the example of x sine inverse x. Third is integration square root of x square plus a square dx equals to x by 2 square root of x square plus a square plus a square by 2 log of x plus square root of x square plus a square plus constant. So, these three important formulations they will help you in evaluating the integrals, certain integrals depending on what kind of form they are. We have already seen in case of the functions which were of the form dx upon ax square plus bx plus c, with a square root, that this can be converted into one of the forms either x square plus minus k square, or even if a is negative then k square minus x square kind of form. So, similarly here if we are given a function which is integration of ax square plus bx plus c, we can try to convert them into one of these three forms and then we can evaluate these integrals. So, these three important formulas they can be helpful for solving the integrals as I showed you. I will give you a quick example. Let us try to find out the integral of square root of 1 minus 4x minus x squared dx. So, you can easily see that you can write 1 minus 4x minus x square. So, you write it as 1 minus 4x plus x square. So, it is x square plus 2x. So, if I add 4 here and subtract 4 here, so this ultimately takes 1 and this becomes x plus 2 whole square. So, 1 minus 4 will become 1 plus 4, that is 5 minus x plus 2 whole square. So, the integral I can write as integration of 5 minus x plus 2 whole squared dx. So, now I can use directly the formula, since it is a linear factor I can use it directly that formula by making a substitution here, x plus 2 is equals to t. So, that the integral becomes square root of 5 minus t squared dt, because here you can see dx is dt. So, this is of the form a square minus t square. So, one of our previous formula a square minus x square, that will work here. So, I will get integral as t by 2 square root of a square minus t square, that is 5 minus t square, plus a square by 2, that is 5 by 2 sine inverse t by square root of 5 plus constant of integration. Replacing t by x plus 2, we get x plus 2 square root of 5 minus t square, that is 5 minus x plus 2 square, and this is same as 1 minus 4 x plus x square. So, I will directly replace this one, 1 minus 4 x plus x squared plus 5 by 2 sine inverse, t is x plus 2 by root 5 and then plus constant. This should be x plus 2 by 2, that is the answer. So, with this we come to end of this lecture. So, in today's lecture we learned different techniques of using integration by parts, and we saw that how it can help us in solving certain integrals which we cannot solve by using any known techniques which is known to us till this point. In further we will see some more examples. Thank you.